Hey guys, welcome to the 7th video in this Flame game development series where we are making Ski Master, a top-down vertical scroller about skiing. In the last video, we added the trail colliders, and using that, we implemented a way to respawn the player character back at the start of the trail when it stays outside the trail for some time. So in this video, I'm going to double down on the respawn feature and add a checkpoint system to the game. But before we proceed, I'll quickly run through some minor changes that I have already made since the last video. The first one is in the pubspec YAML file. Here I've upgraded Flame and Flame tiled package versions to 1.11 and 1.18 respectively. Luckily, none of the breaking changes introduced in these versions affect our code. Next, in the settings.dart file, I've increased the width of the size boxes. I had to change this because I noticed that the default text size of switch list style got increased after I upgraded to the latest Flutter SDK. So make sure you have got these changes if you are following along with this series. Okay, now let's open Tiled and start adding the checkpoints. To save some time, I've already created the level 2 map. This one has a bit longer snow trail with multiple branching paths. But notice that rest of the layer and object placement setup is still the same. I highly recommend you to try making your own level if possible. If not, you can just copy my TMX from the GitHub repository of this project. Link will be in the description. So to mark the checkpoints, I'll go to the trigger layer and I'll activate the insert rectangle tool. Now I can just place rectangles anywhere across the trail. And to mark it as a checkpoint, I'll set its class property as checkpoint. And let's set the name property to checkpoint as well. Now it is up to you to decide where and how many checkpoints you want along the trail. In my case, I'll just place 4 checkpoints in total. And I'm placing them such that they cover most of the branching paths. And while we are at it, let's also place a rectangle at the end of the trail. I'll set the class type for this as end and name as trail end. We'll use this to detect if the player has completed the level. And let's quickly mark the end for level 1 as well. And once we are done with that, let's make sure to re-export both the maps. Okay, now back in the code, the first thing that we need to change is the level loading. In the onload of gameplay class, you can see that we always load the level1.tmx file. But we already have access to the index of current level in this class. So to load the level based on the selected level index, I'll use string interpolation here. With this, we just have to be careful about the naming convention for all the levels when we export them. So let's quickly build and run this to test it. On the level selection menu, I'll select level 2. And as you can see, it has now correctly loaded the second level. Now let's exit from this level and try to load level 1. And yes, this seems to be working as expected. Now let's see how to handle the checkpoints. So if you remember, last time we added this handle triggers method in the gameplay class. This is where all the objects from trigger layer are handled. Right now, it only handles the trail objects. So to take care of the checkpoint objects, I'll add a new case here. And since I'm sure that the checkpoints will always be rectangles, I'll use the rectangle hitbox class for them. For the position, I'll use the object's XY coordinates, and for the size, I'll use the width and height. Collision type for these hitboxes will be passive, and similar to the trail hitboxes, I'll add them as child of the map component. Next, to handle the collision between player and checkpoint, we'll need to set up the onCollision start callback. So for that, I'll create a new private method in this class called onCheckpoint. This method will need the checkpoint hitbox as input. Inside this method, I'll first update the last safe position with the checkpoint's absolute center position. What this does is, whenever reset player method is called the next time, it will reset the player to the center of the latest checkpoint that the player had entered. And as a small optimization step, I'll remove the checkpoint from the component tree once the last safe position is updated. This won't make much of a difference, but once a checkpoint is triggered, it is of no further use anyways. so it is better to remove it completely. Okay, now we can use this method to set up the on collision start callback of checkpoint hitbox. And just for quick testing, I'll set the debug mode for this hitbox as true. Now let's start level 2 and check if the checkpoints get placed at the correct locations. And yes, you can see that the checkpoints are placed correctly. And it also gets removed once the player collides with it. And if I try to go off trail now, you can see that we get respawned at the center of that checkpoint. And to check if it works for multiple checkpoints, I'll trigger another checkpoint down the trail. And as you can see, going off trail now respawned the player at the latest checkpoint. So this seems to be working perfectly fine. Next, let's add code to handle the trail end objects too. Class type for this case will be end. The code for hitbox creation will almost be same as the checkpoint hitboxes. The only difference will be in the on collision start callback. Here I'll create a new method called onTrailEnd and use it in this callback. Inside this method, the easiest thing that we can do is call the onLevelCompleted callback. With this call, the player should be presented with the level complete menu. Let's quickly give it a try to see if that works. And yes, you can see that we do get the level complete menu. But the game still keeps running in the background and the player still gets respawned once it leaves the trail. To fix this, I'll introduce a boolean member called levelComplete with its initial value as false. Then in the onTrailEnd method, I'll set levelComplete to true. Now in the update method, we can make all this reset timer handling logic to execute only when the level is not completed. Next, when the level is completed, I'd like to make the player slow down. It is possible to reduce the max speed of player on level complete to achieve this. But I'd like to show a cool way of slowing down or speeding up components. So in the player.dart file, I'll add the hash timescale mixin to the player class. This mixin exposes a timescale member of type double, which can be modified to scale the delta time of that component as well as all its descendants. The only condition is that the component's movement logic must be frame rate independent. That is, it must be using the delta time for its movement calculations, something that our player class already does. Now, once we add this mixin, we can go back to the update method of gameplay class and set the time scale of player as 0.25. This means once the level is completed, the player character will be slowed down to 1/4 of its normal speed. So let's hot reload the game and see this in action. And as you can see, the player does get slowed down at the trail end, and it also does not get respawned. This is fine, but the sudden slowdown feels a bit odd. Also, the player can potentially still keep on going forever, which I definitely don't want. To fix this, our good old friend lerp double can help us. So instead of directly setting the time scale, I'll make it lerp from current value to 0 with a time scale rate of 1. Now let's restart the game to test this. As you can see, now the player slows down gradually and eventually comes to a halt. Also, if I press the next button, you can see that it correctly takes us to the next level. And that is all for this video. We now have a working checkpoint system in place along with a way to detect when the player completes a level. So I hope you enjoyed this video and learned something new. If you did, do hit that like button, consider subscribing to show your support, and I'll see you in the next one.